Good morning. All right, first start of the day. Very nice to have you here. Thank you so much for coming and spending your day with us. My name is Craig, and I look after a few of the businesses for AWS in Asia Pacific. So running our AI, our big data, and analytics business. So what I'm going to share with you today is around the building patterns that some of our best customers use when they're building analytics solutions. So let's kick off. What I'll share with you is if you look at some of our best sort of marquee customers, and we talk about Netflix and Airbnb and DBS Bank and Air New Zealand, there's some common patterns of how they build their platforms. So what I'm going to take you through today is sort of what a normal starting point looks like, particularly for enterprises, as they start at day one and they build forward and they build more advanced analytics platforms. So the company that I'll share with you, the company's name is Ear Ecstasy. Now, you had to forgive me, it's actually not a real company, but the most important thing about them is this is the actual journey that most of our customers will go on. So I want to take you through from day one, and the story of Ear Ecstasy is they are a B2B company. So think back maybe 2005, they were creating high-def headsets. And they were sort of a traditional manufacturing company. They had great equipment, they gave it to a distributor sent it to a retailer sold it to customer. Ear Ecstasy had no idea how their customers use their product. They had no relationship directly with the customer. So we fast forward, and in 2018, Ear Ecstasy has released this great product, and they're called Smart Buds. Now, Smart Buds, what makes them interesting is they're connected headset. They also have heart rate monitor, they have GPS detection, they even pair with a mobile app, so that you can do things like take a picture and it can relate what you're listening to the scene, the picture of what's around you. That's pretty interesting, right? So they now are moving into a space where as a manufacturer, for the first time, they will have a direct relationship with their customer. So what I want you to think about is which parts of this might relate to you if you're looking at measuring signals from customers and having a more direct relationship with customers through data. So let's kind of go down this journey. Now, the first thing that we'll see is, as most of our customers in this Ear Ecstasy will start kicking off projects, sometimes in the traditional sense, like if you look back how people used to build analytics projects, they'd start with the data, right? So they say, hey, we have this data, let's pull the data in and let's build something with it. But actually a really good pattern tends to be starting with solving for two personas first, solving problems for the head of finance and solving problems for the head of product. So in this case, we'll talk about Ms. Lim, and Ms. Lim, she heads up the finance group. Now, she's got some very specific questions, and those questions tend to be around, well, what's the impact? If there's issues with production, if there's quality issues, how does that impact my cost of sale or cost of production? Looking at inventory holding costs, looking at supplier performance. These are very traditional things that finance needs to understand. Now, Raymond, sitting on the product side, and Raymond, he has questions that are more around how do people use this product? And what's the demand forecast? What does a customer segment look like? So again, solving the sorts of problems that have to be solved first before they can build further. Now, in the traditional world, the way to solve this problem was, we know that we have a certain amount of capacity that we need. Let's go buy something big, right? We need to look forward maybe 2 years or 3 years and thinking about getting capacity. Well, that model is really hard because starting with, I need to look forward 2 years or 3 years and I need to make the capital investment today is a very difficult way to start. So Ear Ecstasy has moved from having appliances to using data pipelines. And what you'll find is that as you look at some of the best AWS customers, they're rewiring how they think about data. And instead of storing everything in a big place, they start to lay down pipelines of data. So this is, again, and we'll show how this is one of the best patterns for being able to move quickly and be very cost optimized. So only spending on what's actually being used and being able to move very quickly, getting data from source into insights. So, okay, so data pipelines will go a little bit deeper as we move forward. Now, the first set of projects that Ear Ecstasy and really most of our customers, they work on first are projects around modernization and consolidation. Now, for you and your terms,
You might be talking about 360 view of customer, 360 view of business. These are the typical projects that will kick off the first build of these platforms. So again, modernizing and pulling together data. And it's to answer specific questions. So again, a good project tends to start with solving problems for the finance group. And specifically because the finance group has data analysts. Now that seems like a very nuanced thing, but as opposed to trying to upskill departments that have never done data analytics, starting with finance, starting where they have the existing skills, and then helping to answer some of those questions. So Lim has the questions around impact analysis, supplier performance, looking at inventory holding cost. She knows that that data probably lives within the CRM system and the ERP system, right? So going back to the traditional sources of where this lives. So looking at order history, looking at return history, even looking at what has been for production, what do we have currently in inventory. So being able to leverage all the existing data assets to answer those specific questions. Now, I'm going to show you a pattern here, and you'll see this pattern through this presentation and throughout the day. So we talked about data pipelines. Now, a data pipeline is the way to bring data from a source to a persona or to a user. Now, there's a few steps in this that are pretty common. So you have to ingest, or you have to pull the data into the cloud. You store the data, and then it goes through a cycle. Store, analyze it, put it back into storage, analyze it, and then at some point you visualize it. Now, this data pipeline is going to start, instead of just seeing one of these, as more projects are built, you'll see 1, 2, 3, 4, 5. Many pipelines will flow from the source into the data lake and into where the user gets it. Now, there's a part here we'll look at first, which is the data pipelines, and then I'll fill in the bottom part later, which is the event pipelines. So this pattern here, let's dig into it a little bit. Now, the key to answering the question, and again, moving away from start big, is we think about, to solve Lim's question, how can we start really small? And then once we find that there's an answer, we start to iterate. So start small and iterate. Now, the source systems that she had were, on the left side, we have the ERP and have the CRM system. And in this case, they're using Oracle Financials, that's fine, and using SAP R3. Very traditional back-end systems. Now, because they don't want to lay down a lot of new tooling, she says, what if we can just use the existing Oracle technology, and we can use maybe Data Pump. So use Oracle Data Pump to move things to S3. That's okay. And for SAP, they said, well, to pull out of R3 is a little bit complicated. And if you've ever tried this before, normally you'll set up BW, and then you have some BW extractors, and there's a lot of licensing that you have to put in place. So they use Bright. And Bright is just one of our many technology partners. And they happen to be very good at pulling data out of S3, or out of R3 and pushing it into S3. So just as an example, now in your case, we've been building cloud, been building tech partnerships for about 12 years. So there's a lot of stuff there's a lot of different capabilities in the ingest layer for really whatever source you might have. Now, the data first lands into a raw data area. Now, if you're building data platforms for the first time, or if you've come from a traditional world, sometimes there's been a thinking of take all the data and put it into a data warehouse. But data warehouses aren't very flexible. So what we see for a good data pipeline is have a landing zone, have a place where raw data lands first, and then start to take that and push it through into a data lake. Now, there's going to be a session following this that goes into the details of data lake, so the design pattern for data lake. But for right now, I'll just give you some of the highlights of that. Now, she remember she had some very specific questions, looking at impact analysis, looking at supplier, and looking at holding cost. She just wants to pull enough data out of financials and enough data out of ERP to answer those questions. If she finds that the data is good, then she will go back and make a request to the data group that will do an export of the next layer, an ingest of the next layer. It's very different from doing a bulk load of everything to start.
So again, just starting to answer a few questions first. Once the data arrives in the data lake, now she is a data analyst, and the finance group often has the skills to use SQL or to use Tableau or to use any number of analytics tools. Tend to have two kinds of questions that are asked. One is going to be looking at performance, and performance is a dimensional question. What does it look like across product line? What does it look like across time? Looking across dimensions. Data warehouses are very good at answering those questions, and it's why we've looked at things like cubes and warehouses in the past. So Amazon Redshift, and I'll talk in just a few minutes around what Redshift provides, but Redshift is a cloud-native data warehouse that's good for dashboards, dimensional queries, basically things that have a full schema or dimension. There may be some questions like, what's the impact analysis? If I had a problem in my production line, how did that impact my cost? Well, there's not a good schema. That's very hard to put that in the warehouse. So doing a direct query sometimes where you're doing a schema on read, that can be a very useful thing for somebody who's a data analyst also. So using a service like Amazon Athena, which allows you to query data in a data lake without having a schema attached to it. So just go ask questions of the data, merge it in real time. She might want both parts of functionality. So again, Tableau user, being able to hook onto fully schema data and semi-structured data as well. So let's talk about Redshift. Redshift, if you are not familiar with it, is a product that we launched several years ago, and it's a cloud-native data warehouse. There's a few things why our customers tend to use Redshift for their analytics and reporting. You've got a few features. One is that it's designed from day one to be scalable, both at the small end and at the big end. So it is a fully columnar data warehouse, and which means that you can issue queries that run quite fast instead of doing row-based table scans. It's also about 1/10 of the cost of a traditional data warehouse. So if you are sort of in a world where you're used to spending $1 million, you may be looking at 1/10 of that just to be able to have a full-scale data warehouse. It also can run starting with a few gigs, so you can start a really small cluster and only pay for that and go all the way up to exabytes. So again, designed to scale from the beginning. From formats, we again have been building this to work against a number of the open source formats, so columnar form, to be able to pull and ingest those. Have designed, again, where you can, if you have security requirements where you want to do encryption at rest, encryption, bringing your own keys, we do have facilities for that. So talking about the data lake, so that's the consumption, right? So that's the data warehouse. But what is the data lake? And you probably have heard data lake, data lake, data lake from so many places. So what really does a data lake need to have? The first thing is just to tell you that AWS does not provide a data lake product. What we have is we have a combination of tools that tend to be used together in a very repeatable pattern. Now, the tools need to be able to do a few things well. Today, you might be using structured data coming out of a financial system. You may have transaction logs. You may have web logs. But tomorrow, you might want audio logs or video or geospatial data. You don't always know what you'll need going forward. So we need to make sure a data lake is flexible for any kind of data in the future. The second is, if I look across this room, there's a lot of smart people here, but your skill sets are very different. And that's true across the organizations. So some of you might be programmers, some of you might be business leaders, some might be data scientists. Well, you have very different needs for what level of data you go to. Do you want highly contextual data, or do you want very raw, granular data? So being able to access the data lake for the different personas, for different skill sets, and then having access for tools. It's probably a good pattern to say, if you've got PySpark programmers and you have Tableau users and you have people who are using web dashboards, they all need access to the same data without needing to learn new tools. So being able to have a flexible API access. So these are kind of the core traits that we designed the data lake to have. Now, we talked about LIM, and LIM answering very specific questions using financial data and ERP data. Now, let's go to Raymond. Raymond is head of product. Raymond has other questions around who uses my stuff and what's the demand forecast, really understanding the product performance. Now, there's some data, because of the work with LIM, the project, some of that data was already pulled out of financial system, out of ERP system. So, okay, to answer my question of who's using this, I know from CRM, I know what has been ordered. So some of that data is in the data lake, but I think that there's more data, there's something interesting happening around social sentiment. I want to know, for the first time, I'm starting to listen to what are my customers saying across social media channels. Well, that doesn't fit into a data warehouse, so how? What do I do with that? He's looking specifically for mentions, he's looking for trending. So the second concept, we had the first one, which is start small and then iterate, right? So lay down data pipelines. The second is be able to experiment, validate, and then scale. So we go back to this drawing, and we have it simplified a little bit. So on the left side, we saw ERPs and transaction. Now we have social data. On the right side, we now have LIM, so a different persona. Before it was a data analyst, now we have a business user. The first thing he does is he looks in the data lake and says, do I have enough? If I don't, please go back and pull data from these other feeds. Now, I'll simplify the top. We've seen this before. The ERP and transaction data comes through some sort of connectors, and it lands into the raw data area. But now, we see something new. So the event data, event capture, it looks different. The reason, transactional data, you can capture that every hour, every day, and just do a load. But event data is messy. When it comes in, it might be out of sequence. So there's concepts that we have to think about, like windows. Like as events are happening, it's like, okay, well this is a little out of sequence, we may need to put events together. Like maybe in a click stream, say, okay, did we capture all the events in sequence and understand what happened during that event? So there's a special area where we process events first, and we put some context to the event before it goes to the data area, the raw data area. Now the details, if you want to know a little bit, sort of a double click on that, typically you're either using streaming analytics, or if you're operating at the scale of like a Netflix or really large, you probably have a Hadoop cluster that's running Spark with a bit of Scala to handle some of the stream processing before it's pushed up into the data landing area. Now why? Why do we want to capture events first? We typically do 3 things with any given event. Like let's say that you're shopping online and you're using your mobile app. Those events get processed in 3 ways. 1, over time, events are captured to look for patterns, to understand, hey, you shop in this way, we can start to do some modeling of who you are. The second thing is you might want to process events in a whole in real time. How many people are currently shopping on my website, right? What is the current, do we have good performance? What's the click-through rate that we have for campaigns? And the third is for you specifically, when you click on something, the site might want to give you a recommendation, right? So events are typically processed in 3 ways. This is the first. Capture all the events and understand the patterns over time. But then he needs to consume it. Now, Raymond is not like Lim. He's a business user. He's not an analyst. So he's not going to issue SQL code. He's not going to be using Tableau. He probably still wants to use something like maybe QuickSight, which is our BI tool, or any other Power BI or OBIE. Any BI tool can also run dashboards against the warehouse, against Redshift. But streaming data, remember we said there was a second pattern, which is that streaming data, look in that in aggregate. How many people are on the website? How many people are using this product? And using something like Elasticsearch tends to be a really good service for answering that question. And then Kibana, that little icon on the right, Kibana is just a BI tool that's good at consuming out of Elasticsearch. Now the point being is, it's not that any one of these tools are magic, it's that to solve specific sorts of questions, there may be different services or different interfaces that we need to provide to the different users. So let's talk about the data pipelines. Let's go in a little bit deeper. Now, we've shown a very simple view of data comes into an ingest layer, it gets analyzed, and then it gets surfaced. Let's go into that a bit deeper. The first concept with a data pipeline, and if you haven't worked in this space, it's a very important fundamental concept, which is decoupling. Now, decoupling is really helpful because as opposed to needing to get bigger and bigger machines to solve problems, we can start to land data into a very cheap, very durable storage area. And in this case, it's Amazon's Simple Storage Service, or what we call S3. Now, S3 is, and we'll go into the pricing throughout the day, but it's essentially like 2.5 cents per gig per month. And it's got versioning, it's got encryption, it's got all the things that you want with a storage layer. But more important is you can scale your storage as big, it's essentially limitless, as big as you want to scale and only paying for what you're using. Why this is important is as you start to process this data and it moves into a DQ, like a data quality or ETL layer, you now start to treat that as the engine to process the data. Now, I don't know, has anybody here played Half-Life 2? Okay, some, yeah. Unfortunately, it's a different Lambda, but I did love that game. So the Lambda is essentially it's a code trigger. So what that means is that you can now, from a pipeline standpoint, as soon as there is a change, a small bit of data has come in, that bucket, the S3 bucket is waiting. And the moment something changes, it triggers code. And that could be Python, it could be Node.js, there's a few different supported languages. And it pushes the code, or pushes that data to be processed in the next layer, which often is using Hadoop. Now, Hadoop, a lot of our customers, especially at scale, will use something like Spark. Now, you could use others if you want to use Talent or use Matillion or some other ETL tools, that's fine too. The code then gets processed, and instead of staying in Hadoop, instead of having the old model of we need to just store data in this one cluster, the data actually processes and moves into the next part of the pipeline, which is again S3. This becomes the data lake. Now, we show a very simple view of it, which is just the storage, but there's actually some search and some security layer that sits on top of that. So to make that data, give it context and give it a heightened security. Now, along the bottom, you'll see that it says Glue. Now, AWS Glue is a cataloging and search service that I'll talk about in just a moment here. Now, once the data has been processed and it gets put into the next layer, you can actually go back and destroy the raw data if you want. So by pipelining it, you're only paying for the data that you want to keep, right? So you're not locked into, all the data has to get stored for all time and eternity. Now, I show Redshift here that Redshift uses what's in the data lake. However, all of those services, we looked at Athena, we saw Elasticsearch, could be any sort of tool, should be able to access that data lake. So any service accesses the data lake. I'm just showing what the pipeline looks like to move it from raw all the way up to the data warehouse. Now, the underlying storage. We'll talk a lot about S3, and Simple Storage Service is really common for data pipelining and really any sort of data storage for analytics. But it may not solve all of your needs in all situations because you might also want file systems. You might want to run databases that need block storage. So we do have a few different file storage facilities or data storage facilities. So on the bottom, you'll see that there's S3, which is storage. And then we have some archival solutions, which is called Glacier, which is basically a way to age that data to make it cold. We have block storage for databases, and we have file storage, again, if you want to run file systems. So just looking at that in a more holistic way. Now, again, because we pioneered the cloud a number of years ago, about 12 years now, we've been building the facilities to move data into the cloud. So have been building the ingest mechanisms, and it could be file sync, it could be storage gateways. Even have in some regions where you can get the devices called Snowball and load data on that and then ship it to our data center and we load it for you. So many ways to move data into the cloud. We also have a number of facilities for how to use and protect that data. So on the top, you'll see that there's a little thing that kind of looks like a graph or an M. That is called Amazon Macie. Now, Macie, if you're not familiar with it, it's a service that number of our customers are pretty excited about because it applies machine learning to data classification. So you can start piping your data through and it can understand what data classification, if you're in a regulated industry, does it have personal information like ID numbers and phone numbers? So you can start to do identification of what the data means. Then there's other facilities around security, identity access management, key management, and so on. So let's go back. Now, we saw this diagram before. I'm going to start to simplify it, just so I don't kill you with a bunch of icons. But it's the same concept. On the left side, we have the sources. You have the data pipeline layer, and we have the first show of that event capture. What you see now at the bottom, we're showing the event pipeline layer. This leads us to the second set of projects. So the first is modernize and consolidate, like 360 view of customer or looking at sort of pulling together data sources. The second, these tend to be the projects for innovate for new revenue. Okay, what does that really mean? Innovate for new revenue tend to be the advanced analytics projects. Now, to get the first analytics project going, you have to have data you can trust, which is why most customers will start with some sort of data lake project to begin, to say, okay, now we have data that has meaning and it's good enough, and so let's kick off onto the next stage, which is the innovation stage. Now, we saw before that we had 2 users, and one was finance and one was product. The second set of projects tend to involve marketing and data science. Now, they're very different sort of groups, however, and their skill sets are very different. However, they tend to look at solving the same kinds of problems through a different lens. So let's talk about Bala. So Bala, as head of marketing, Bala has to answer questions like, hey, who uses this stuff and when and where? Why do, how do people respond to our new launches? And Christoph he asks the same question, and if you look, but through a different lens. He's asking questions like, what are my segmentations? What is propensity to respond? What is, understanding more around the mathematical or statistical side of that behavior. So, well, what's the relationship? How do these two work together? Let's go to Bala. Bala's questions again around, like, really, what does a person look like who uses my service? Bala's questions tend to be answered first by coming and looking at, it's like, well, where can I observe behavior? Well, I know that that behavior lives in the mobile app. So we've got the smart buds, and the smart buds are collecting some sort of sensor data. But when we bought them, the user registered. Who am I? What's my age? And then they link it to the app, to the phone. Well, the phone captures a lot of usage, but it's not the whole story. There's also data because what do the smart buds do? They play music. So maybe it links up to Amazon Music, or it links to TuneIn or Spotify or any music streaming service. But it links through an API. So Bala knows if I could look at what music's being played, I can understand more about the personality. Who is this person? So collecting data through third-party APIs. Now, this is just specific to this one company, but as I look across a lot of the businesses that we're currently working with, there's a huge interest in how do we capture third-party data. So if you're looking for the pattern for you of how to pull in third-party data, it tends to be through this model that I'll show you. Now, those are the questions Bala has, but Bala cannot answer that on his own. He needs to go out and have Christoph translate that into analytics questions. So the questions that Christoph has, please tell me about user segmentation. Talk about propensity. Talk about understanding, again, sort of the segmentation in that space. If I'm listening to voice, like if I say, hey, smart buds, play me this music, what else can I detect in that voice signal? So he's looking again for the statistical patterns. Now, he first goes out and says, well, data that is dense, and again, this is, if you're not deep on analytics, if you haven't worked in this space, there's a concept of very dense data and very sparse data. Very dense data is data typically that you observe directly. Things that you're watching, a person purchases something. That's very dense. It directly relates to a behavior. Well, that's nice, and so he's looking at what data can we pull that we're observing directly. That should go into the data lake, and from the data lake, I'll do my analytics on that. However, what about the stuff that's all the heart rate? What about the GPS? I think I have some theories. I think I can maybe detect the person's mood if I can look at the change in their heart rate, or maybe I can find out some other things if I look at location. I can figure out, are they exercising or are they at work? But I don't know yet. So again, we're going to move into an unfamiliar territory, which is instead of having nice, dense transactional data, we're starting to use data that is semi-structured and it may be very sparse. I don't know if it has value or not. So Christoph wants to run experiments on that data. This is where we introduce the idea of sandboxes. Now, again, sandboxes, traditionally, we haven't really been well designed as an industry, haven't been well designed to use sandboxes. So sandboxes are designed to be cheap and the ability to test your ideas and use data in a way that you can scale it if it's good and dispose it if it's not valuable. Now we've modified the diagram a bit, which means that the data that was good, that was dense, we've loaded into the data warehouse, or we've loaded to the data lake. But the data that's sparse, that Christoph needs to use, first goes into a sandbox. Now the sandbox, the detail underneath it is, it's still running S3, but it's a segmented safe area. Christoph will access the data in the sandbox. And again, this is an important concept. Not everything goes to the data lake first, because then you start to end up with the data swamp, right? Just everything you could possibly store, you pay for forever. The sandbox is the protective area. He brings in the heart rate data. He brings in the GPS data. He brings in the third-party music playlists and says, okay, let me start to run statistical models. Let me start to use TensorFlow. Let me start to use PySpark. Let me start to use k-means clustering algorithms. Let me try the different ways to see what's in that data. Now, once he has discovered and he's found that some of this data is really meaningful and some is not, he produces two different things. One thing he produces are what I call answers. And answers in the stats world would be called scored data sets. You've run a model, you've come up with some predictions, you've run that against a set of data, and you publish the scored data sets. Well, scored data sets, or those answers, are good for things like marketing campaigns. It's good for reaching out to customers and saying, hey, I think you would like this, or I think this is a service that may apply to you. So that's one thing he produces. Now you see that there's an arrow that now goes from the sandbox into the data lake. That is the data that helped to build those models now gets published. And if you think about how powerful that is, instead of taking all of the data and having to just keep it, you're only keeping the data that produced some results, that was useful in some way. So again, using that pipeline to really narrow down what's being retained. Now, once Christoph has built the answers and he's published them to the data lake, now Bala, the marketing guy, can go back in and say, now I have the models that are published, now I can start to run my campaigns. I can start to answer those questions through my tools. So this is the relationship that is kind of a new one for companies to say how the data scientists actually can feed that data out into the marketing groups. So this is typically how they share that data. Now, let's simplify that again. So you've seen what it looks like underneath, so we'll just kind of get rid of the sandbox and clean that. This layer underneath is called the machine learning, analytics, and maybe for some of you it will be also deep learning. So again, whether you're using the deep learning frameworks or using analytics frameworks, they'll all live within that layer. Now, what's the third and the final outcome? First project being typically 360 view, pull data together. The second is run some advanced analytics and create innovation for new revenues. And the third is going to be respond to things in real time. Now, real-time platforms or real-time engagement, and again, this is just something that I've seen a number of our customers, at the beginning, they want to start with real-time projects, sometimes without getting the other two projects in place first. So this tends to have some dependencies on the previous projects. So I'll show you why. They wanted to answer the question to say, what if, now that we have these smart buds, we could create a personalized life soundtrack so that, and I'll just call her Kelly. Whether Kelly she's doing yoga and she's in tree pose, or she is sitting and reading, or she's at her desk working, or she's at home, based on where she is, what mood she's in, and what she likes to listen to, can in that moment we recommend the perfect music for her, like a personal soundtrack. That's pretty awesome, right? That would be very cool. So in order to do that, what do you have to know, and how could they provide that? So what if we could take those smart buds and she could tap the side and say, oh, I'm really tired, could you play me some music? To answer the question, the first thing is, it's a voice signal, right? So you have an audio file that's captured, has to somehow be translated from audio into text, and then do some understanding with that text. Now, we have some fully managed AI services that do transcription and do natural language processing to understand what the intent is. And the intent is, please play some music, right? But then there's the question of what music? What do I need to recommend? Which at this time we don't know. So there's a second layer that might be running, which is capture the events that are detected where the app is paired to the smart buds. And it's looking at things like location, maybe it's looking at heart rate. It's using other signals to have determined what is her mood in that moment. Where is she? Is she at the park? Is she at the yoga studio? Is she at her office? Based on this, let's pull together the request, the context, use that together with her history, and say, okay, this is the request, and this is what I think that she might want. But if we want a really good recommendation, the problem with just this model is we just keep recommending to her the same things that she listened to the time, and the time before, and the time before. But to make a great soundtrack, we now want to pull together not only history data, but also propensity data. So those models that Christoph built that are around maybe doing clustering, something like a k-means cluster to pull together different user communities, say, not only is this what she may want, but other people have wanted this. So I can start to now recommend to her music that she might really like that she doesn't already know about. So again, a very highly personalized good service, and pulling together voice data for the first time. Now, they wanted to really go off the edge and say, what if I could just pull my phone out and I could take a picture, and then based on the picture, it recommends music for me? Oh, okay, that'd be pretty cool. Let's try that. So how to do it? Well, you see in the picture here, she's got her phone out and she takes a picture and says, oh, I see a desk, I see a chair, I see a lamp. I think you're in an office. It looks like an office. But that's not quite good enough, right? That's not specific enough, because maybe she works at a call center, or maybe she's working at her home office, or maybe she's sitting at a cafe at a shared workspace. I don't know. Well, there'll be different kinds of moods, right? Different kinds of scenes. So there's a concept, and again, if you haven't worked in the machine learning space or in the deep learning space, there's something called image classification. And image classification is you take a whole bunch of pictures and you're able to detect not just the objects, which is what Amazon Recognition does, but let's say you want to be very specific and tune it for your environments. There's a process called transfer learning. And transfer learning is where you take a set of known models, like maybe image classification models, and you import another 1,000 or 10,000 images specific to the kinds of scenes you want to identify. Using something like SageMaker and using image classification retraining, doing transfer learning, they wanted to tune specifically for different environments. I want to even know what kind of office. Is it a quiet office? Is it a home office? Is it a shared workspace? So being able to retrain those models, now not only do they know I'm in an office, but specifically, this looks like a quiet office. And based on that, a quiet office, now I can go back and look at, well, historically, what have you listened to when you're in this environment? What you listen to at work versus at a call center? You could even go further and match this together with similar users, right? So again, this very highly customized, using data that they had never used before. So looking at image data, and image data to produce recommendations. So again, for these models, this might be within the space of a connected device, but we've seen how social data can fit in and be explored in the sandbox, how voice data can be processed, how image data. So again, really using this same sort of pattern to be able to build very complex or very mature sort of designs. Now here's a simplified view of it, and I'll talk through a bit. The top layer we've seen, so the data pipeline initially is capturing behavior to build the models, to understand what's normal and not normal, and what groups of people are very similar. If you remember, I said Christoph creates two things. One are the answers, right? The scored data sets. The second thing that Christoph creates are models, predictive models. Predictive models are pushed from where it says machine learning analytics, it's pushed down into a scoring layer. That scoring layer is just waiting for events. It's waiting for the voice for her to say, hey, play me music. It's waiting for that picture. When the event is captured, the event is then processed and moved up to the scoring layer to say, I received this voice file, what do I do? The underlying AI service, those are the fully managed services for voice processing, for image processing, to pull out the context. What was said? What was the text? What tags do I see within the image? And now based on that, please give me a propensity score, which you might think of as 85% likely that the next thing that she would like to listen to, that Kelly wants to listen to, is this song. Please recommend it. For you, that might be any recommendation service that you have either to your consumers or to like an automation system within your business. It's the same pattern. So if you dig down and you go and you look at our reInvent presentations, this is how Airbnb processes, this is how Pinterest processes, capturing requests, processing recommendations, and pushing those out to the users. Now where it says action, there's, again, depending on the type of configuration you have, the action could be something like take that recommendation and stick it into a caching layer. Stick it into a NoSQL layer if you have mobile applications that need to be very low latency response. So again, there might be some slightly different configurations, but the pattern is almost always the same, whether it's for ear ecstasy or for a lot of our other customers. So the three projects that we've seen. The first is around modernize, consolidate. And again, if you're kind of thinking about like, hey, are we trying to do a little bit different things around those 360 views or around pulling together the consolidated view of the business? The second are often around personalization projects. So understanding segments. And again, in the analytics world, just talking about who are the groups of people who look similar? What are the groups of behaviors that are related? What are the groups of products that we can start to make some forecasts around? And the third is around real time. Now that real-time engagement depends on having good predictive models. In order to be able to give a good recommendation, you have to know what have we seen in the past, what can we expect for the future? How do we think a person will respond? So this is why we'll tend to have this sequence, series of projects A, then B, then C. So that's kind of the dependencies. Now, what about for you? So you've come here today, you've decided to spend your day with us, which is awesome, and we really appreciate that. So what do you do when you go back tomorrow and you're back at the office and you want to build? The first thing, and again, just taken from having, I've been working in the analytics space for about 20 years now, and have been working in cloud for a number of years, is that the kinds of projects that are successful for our customers tend to first start with ones that impact new revenue. So what I really strongly recommend is instead of looking at solving the big problems to start with, shortlist a set of projects. Try to get down to a few that are around creating some sort of new value for the business. Start with those, and then over time look at the optimization problems. The tendency, and again, I'll just sort of share this of, you know, I do strategy workshops with customers several times a week, and the tendency, like, they want to go and fix a problem that exists that is around optimizing, that's around cost savings. And those projects sometimes get stuck for a period of time because the only people who care are sitting in the finance team, right, around cost savings and profitability. However, the projects that are around creating a net new customer segment or creating a new experience for customers are really powerful for the business. And people understand it, and they learn, and they iterate. So again, just from my experience, that's something I've seen as a really good pattern. The second is by starting to use things like data pipelines and moving into decoupled architectures, the ability to move data and to build that is so much faster. You're not looking at a 9-month provisioning time. You're not looking at 6 months of doing RFPs. You can start to lay down projects very quickly and test them. And just to kind of share with you what those cost models, as opposed to having to spend a huge amount like $500,000 or $1 million to get started on your first project, a number of our customers will budget $150 to $200 per experiment. If you put the cost of that out and say, hey, we want to run 100 things, and those 100 things are going to cost us 10 grand, that's really, really powerful. And it's why our customers tend to move, the big ones tend to move really quick, because they can run a lot of stuff in parallel. The final is, if you are building for the first time, some of these are new concepts, and maybe you've got people who have AWS skills, maybe you have AWS skills in-house, and that's great. If you don't, and you're saying, this looks good, we want to get started, we have a role, we have 2 different roles that I really suggest you take advantage of. One is a solutions architect. It is a role that we do not charge for. So it's a person that once you have a relationship with AWS, you can knock on your account manager's door and say, we have an idea, can this person help us with the design? And what we call the SA, or the solution architect, their job is to help you with the design so that you go down a good path. And again, it's a service that we don't charge for. Now, if you do want hands-on keyboard and you want somebody to help you build, then we do have professional services also. And then I think through that model, you can kind of estimate how you would find out scoping that and then working on those projects. But at a minimum, I would say talk to our SAs if you're thinking about building. So with that, we're always interested in getting your feedback and seeing which parts of this are useful, which parts are helpful. There are 4 more sessions in this track today where we go deeper on data lakes. We go deeper on serverless data pipelines. We'll go deeper on some of the other topics. So I do recommend, if you have the time, to please join us for the rest of the topics today. So with that, I want to thank you very much for coming and spending your morning with us. If you do have questions, I'll be around for a little bit longer, and I hope you guys have a fantastic day. Thank you.